Hello everyone. So in this video, we are going to level up our testing skills by writing more complex tests. As we have already wrote a small test for a typo, now we are going to level up our testing skills by writing more complex tests. So let's get started. So we'll start writing tests for our home screen. The aim here is to cover all the cases possible in this home screen and then refactor into a better design or use a better state management solution here. In order to write our first test, we'll use the same strategy. We'll start small. So for example, the first test we would be writing is like the default case basically. So whenever the home screen is loaded, we'll be showing the no task added. So let's write that test. When we're writing test related to something, Flutter provide a way to logically group all those test cases. So here I'm going to use a group where I'll name it as a home task list, and then I'll name that individual test as to no task added. Now, since this is a default case, we need to just load the home screen and match that text. So what I'm going to do is I'm going to basically copy this, and I'll remove the tab here because we don't want to tab here, and I'll just change the text here to no task added. And now I'll just run our group test. So it passed now. The interesting thing is that if you run the code coverage, you won't see much difference between what we have done previously and now. You see, it's pretty much the same. When you go into home, it's the same amount of percentage we have. Nothing is much change. The reason is because when we ran this test, it already ran this no task added test. Now the first thought will be in your head that why can't we just assert this here, match two things at once and just get rid of this test? Well, you can do that, and it will also follow a dry principle that you don't want to repeat this whole thing again and again. But remember one thing, that while writing tests, don't get obsessed with dry principle, which is basically don't repeat yourself and try to avoid duplication. Try to instead follow DAMP, D-A-M-P-E, which is basically says descriptive meaningful phrases. The reason why is that the test we are writing should be more expressive and it should document one behavior at a time. So if you follow dry on test, it will have a less duplication, but it will also be less descriptive. But if you follow DAMP, it will be more descriptive, but it won't be dry. Like whenever I come to this test, I should know what it's doing. It's just like loading a home screen and then pumping it and testing the widget. But if I try to, add it here, the problem here is that if we mix multiple behavior in a single test, then it will be very hard to identify the cause of failure. If this test failed the completed task, but if it's passing no task added, this test eventually will fail. And it testing two things and just implying that it's just testing one thing here. So here the no task added test will fail without any actual issue happening in the production because the completed task failed before that. So just try to avoid that and don't worry about duplication until unless you have some utility function which you require for setting up testing and making the basic operation. We'll see that example later. Now let's write a little more complicated test, which is basically matching an item in list. So example, I'll write a widget test here to show task item in the list. Okay, so what this test will do is basically when we create a task here, I'll just create a title 1. I'll add that to Android project, and it will show in a to-do list. So we want to verify that the title and the project has been shown properly on this list. Let's write that test for it. So what we are going to do is we are going to do the same thing here. We are going to load the home screen here. So there are two ways. One, click on a floating action button and then add a task and then show up the list. And another one is when by default you start an app, if there is something in the database already, it will show up on the screen. So here we want to verify that whatever is there in the database should show up on the list. So here we are going to directly assuming that something is already there in the database, and when we load the app, it should match two text, basically task 1 and the Android. Now one thing is you are seeing is a common pattern is basically wrapping this into material app. So I have talked about this previously, that this is something, you know, we can follow dry principle and extract it out. Since we are going to use this in all the tests, what I can do is I can extract an extension method called widget wrapper on widget, and then done. So I've created this extension function on the widget, so you can just use this wrap with material app and it will wrap this whole same logic around those widget. So this way you can create multiple wrappers as per you need it in the test. So what I will do is I'll just go here, remove this, and we'll wrap with material widget. So this is how now it's look like. Now just verify if everything is running fine. So you see our home task is failing. I'll just show all the past test here. So our home on show task item in list is failing because it's not able to show the task 1 and Android. The reason why this happened is because we don't have anything in the database to load here. Now as we can see that when we try to run this test, it needs to fetch data from database in order to show on the screen. But we don't have real database in test. And this is one of the most common hurdle a developer come across while writing a test. Like on the initialization, there might be an API call, or they would be fetching some from the database. The developer who is not familiar with test, the first thing come in their mind is, how do I use that in test? How do I mock it or fake it? So basically there are multiple techniques to do that, but I'm going to talk about the 3 main approaches we can take to tackle this issue. And you might be wondering how I learned this technique. I learned this from a book called Working with Legacy Code. In order to use any of these 3 approach, first we need to understand how our code base is structured. So let's go to the home screen. And if we see that the updated task we are getting is from class called app database, which is returning get, and we are using this query and then updating the task list. So on the home screen, since we don't have any task here, it is not showing up on the screen. Now, since we cannot have a real database in the test, you can mock it or you can fake it. In our case, we are going to fake that. But how do we do it? Because currently it's using app database.get, and if you go into get, it using a singleton. And this is one of the common thing you come across app, that the database or API call is running singleton, and it's being used everywhere throughout the app. So this is one of the reason that most of the people in the community say that the singleton are bad, because those are global variable and the single instance is used across the whole app, and it's very hard to track where it's coming from and what causing the changes. And it also make it harder to write test, which is in our case. So here we are getting the get and it's turning the empty database. Our test is failing because we are not able to find that text. Now, if you have a static method like this in your app, the first approach would be to introduce a static method which replace your actual instance. Basically replace your original static instance with a test instance. To demonstrate that, what I can do is I can create, let's say, a method called static void set test instance all app database, and it will replace app database. Now you see I have given the name here is a set test instance because I want to differentiate that this method has only been used in test. We are starting with this because we don't have any other way to go around with. So once we have a test in place, we can refactor this class in a better structure so that we can write test easily. Now we cannot set the app database instance because it's final. So you need to remove final here in order to set it. Now you might be asking that we are not keeping it final, then it will impact the immutability of the singleton. I mean, as I discussed before, there's a trade-off between doing this type of things. Here we are trading off the immutability in order to write test. Once we have a test in place, we always have a possibility to restructure this into a better shape and get back immutability. So what this method will does is basically it will set the fake instance we are going to use, and when it call get, it will use that database instead of the internal they create one. So let's go to the test And in order to create a fake, we basically will override the method which is used to show this text. So if we go into home screen, and so here is the list which we are showing, and we are getting this task list. And if you check the usage, you'll see it has been add all here, and it's coming from get task. So what we are going to do is we are going to override or fake this get task method. So if you see, it will directly call the database and fetch the stuff, and this is the part of app database. So I'll just create a class called fake app database, which will extend app database. The error is the superclass doesn't have a 0 argument constructor. So the problem with the singleton is that if you have read the book Effective Java, where they demonstrate how to create a perfect singleton, the first rule is that since you can't have multiple instances of that singleton, you have a private constructor. And since we have a private constructor, we cannot extend it. So in order to create a fake, we need to remove this private constructor. Now, this is also second big trade-off which you will have in order to make the test work. And since we have removed the internal here, the internal won't work. So now anyone can create the app database, but the get will give the created on the top one. So just let's get back to our test. Now you can see we can fake the database. Now we'll override the our get tasks method, and if we care about the parameter, then we use this parameter. But for now, since we are writing test, we'll just return a list here with the fake data we want to create, and it required future dot value. Yeah, so let's just create a fake task. Let's just see how can I create it. Okay, so there's a constructor here. I can use this to create a task with title and project ID. So I'll just create task dot create. Title is equal to, we want title 1, project ID can be 1 anything, and then we'll create a new instance here and then pass the task here. Now we have override this get task, but how to use this fake app database in the test? So what we are going to do here is we will come here and we'll create an app database and set instance, and here we are going to set our fake database. Now what it'll do is, since we have set fake one, it'll set the fake one here, and whoever calls it will get the fake one itself. And then if someone calls the function get task, it will return this fake task. Now let's run this test. Okay, it's failing. Why it's not task 1? Oh, okay, so it's a task 1. I need to make it task 1 and run it again. So here's the error. The root task here. Okay, so the problem is we don't have a project name yet. So what we can do is we can, yes, we need Android as well. So what we can do is we can set task project name is equal to Android, and there's a project label as well, color as well. So I'll just set colors dot green dot value. So basically you need to figure it out what model you are using in order to show that, and try to fake that model here. Since the project name and project color was easy to just make as a setter, but in some cases, in your case, it might not be there. So you need to restructure your model in a way that which you can edit this project name and color in a test. Now let's run this test. And it failed because task 1 is not found. Okay, so there's a typo here, task 1, and here it's required 1. So now let's rerun it. So now it passed. So basically that's how you replace a static instance with test instance. The advantage of doing this is basically that you do a very minimal code change in your production code. As you can see, we can wrote a lot of code in order to fake it and write in a test. But if you go to the app class, we did only minimal changes here in order to get this class into testing. There are few gotchas you need to take care of, that when you use this set static instance, since we are only using it once, this use the fake app database here, and for other tests is use the same. So you need to either clean it up on setup and tear down, or you need to update this set state instance in each of the class, so that you can differentiate between the fake database and actual app database. And since this app was a simple, you can directly get the app database and just make a fake it here. But this might not be cased with most of the complex app. There might be a lot of dependency happening in the home screen. So currently this app only fetches from a database, but you might be doing a combination of an API call and the database. So there might be some class which have extracted that logic, or it might be possible that both are happening on the same screen. For example, that first you show the list from the database and then you get an API call and you update that list. So in that case, you need to figure out how the dependency graph is structured, what things you need to make it fake in order to get started. One good thing about doing this set test instance will give you an idea that how complex your dependency graph is. For example, if you need to set a lot of set test instance here, or you need to do a lot of mocking, or you need have a lot of dependency which you need to fake it, so it's better to extract that into a single class and then mock it or fake it. For example, if you have a fake app database and fake API call both happening here, it's better to extract that into a class called data source, where it will keep the logic of fetching from a database and the network and just give you the list. So then you can just fake that data source here, so you don't need to care about where it's API call or where it's a database. So yeah, that's how the replace static method work. Next, I'll show you another way of solving the same problem. I'll talk more about those approaches and techniques in upcoming videos, so just stay tuned. So if you like this video, then please like, share and subscribe. Thank you.